Okay, so the question said the diagram shows an electric circuit with 4 resistors. So these are 4 resistors: R1, which is 100 ohms, R2, which is 250 ohms, R3, which is 350 ohms, and R4, which is 200 ohms. So this question wants us to find a few things. So the first thing we're asked to find is the resistance of loop A, which is this loop here, right? So our first objective is to find the resistance of this loop. So if you look at this loop here, it's actually a parallel branch with these two resistors R1 and R2 connected in a parallel arrangement. Now I've done a video talking about series and parallel circuits. You can always check that out for more information on series and parallel circuits. So let's start with number 1. Alright, so the resistance of the loop A. So to find, so we can say resistance in parallel. And to find resistance in parallel, we use the formula 1 upon RT. In this case, we can say 1 upon RT is equal to 1 upon R1 plus 1 upon R2 plus as many resistors as we have in parallel. In this case, we only have 2 resistors, R1 and R2, so we can write 1 upon RT is equal to 1 upon R1 plus 1 upon R2. So here on now, we simply fill in our values. So 1 upon RT is equal to 1 upon R1, which is 100 ohms. R2 is 250 ohms. So 1 upon 250 ohm. Right? At this point now, we simplifying our LCM, which again is our lowest common multiple. So in this case, our LCM is 1000. So we say 100 into 1000 from algebra goes 10 times. So we have 10 multiplied by that. So we get 10 plus 250 into 1000 goes 4 times. So we have 4 times 1 gives you 4. Right? And then we write 1 upon RT is equal to 10 plus 4 is 14 divided by 1000. Now if we were to go ahead and divide this answer here, we would actually get the inverse of the total resistance, because as you can see on the left side here, we have 1 upon RT, which is the inverse of the total resistance in the parallel loop. So to find RT, we simply flip both equations. So we have RT is equal to 1000 divided by 14. Okay, so let's grab our calculator and then we can find our answer here. So RT is equal to 1000 divided by 14, which equates to 71.43. So we can write 71.43 ohm. That's our resistance in loop A. So we can say RT loop A is equal to 71.4 ohms. Now part 2 in the question wants us to find, what does part 2 says? Part 2 wants us to find the resistance of loop B. So let me change color here. Let's go with a red. Let's go with a red there. And we're finding the resistance of loop B, and this is our loop B. Alright, so taking number 2 right here, we can write, again it's resistance in parallel, so we write resistance in parallel. Using this symbol, these lines to represent the parallel. We write again 1 upon RT is equal to 1 upon R1 plus 1 upon R2. And again, these R1 and R2 are basically placeholders for our values here, right? So this doesn't mean that we're taking reference to R1 in the circuit. It's just the expression, and we're referring to the resistance as R1 and R2 just for convention, right? So we continue by writing 1 upon RT is equal to, in this case, R1 is 350 ohms. So we have 1 upon 350 ohms plus 1 upon 200 ohms. And just like we did in part 1, we find our LCM. In this case, our LCM is 1400. Right, so 350 into 1400 goes 4 times. So we have 4 times 1 gives us 4, plus 200 into 1400 goes 7 times, right? So we continue by writing 1 upon RT is equal to 4 plus 11. 4 plus 7 is 11 over 1400, right? Then, since this is the inverse, we simply flip both sides and get RT is equal to, so RT is equal to 1400 divided by 11. So RT then is equal to 1400 divided by 11. And we get 127.27. So 127.27. And again, units of ohm. So we can say RT for loop B is this here. And again, our resistance for loop A was this. Now the question says we should find the total resistance in the circuit. So if you look at the circuit again, loop A and loop B are actually in a series configuration, right? What I mean by a series is that loop A and loop B are connected in a chain-like manner. So we have a series configuration here. So to work part 3, we can consider an equivalent circuit with 2 resistors, because effectively what we have done before, we have found the total resistance of this loop here and found the total resistance of this loop. So we can replace this loop with an equivalent resistor, and this loop with an equivalent resistor. And those equivalent resistors would be 71.43 ohm and 127.27 ohm respectively. So let's redraw our circuit. Again, we're doing part 3. So we can redraw our circuit. We have our source here, our 24 volt source. Then we have a resistor here in series with another resistor. So this is 24 volts. And loop A was 71.43, so we can replace this with a 71.3.43 ohm resistor, and loop B with a 127.27 ohm resistor. Now for resistors in series, we find the total resistance. So let me write resistors in series. We find the resistance by basically taking the sum of all the resistance in the series branch. So we can say RT is equal to R1 plus R2. So using our calculator again, we can say that first, we know that R1 is 71.43 and R2 is 127.27. So using our calculator, we can add these up. 71.43 plus 127.27, and our answer is 198.7 ohm. So that's the total resistance in the circuit. Now part 4 wants us to find the current flowing in the circuit. Now to find the current flowing in a circuit, we simply, before current flowing, if you remember from Ohm's law, we know that for a resistor at a constant temperature, the current flowing in the circuit is directly proportional to the voltage drop across the resistor and inversely proportional to the resistance of the resistor. So we can write Ohm's law then as I, which is the current flowing, is equal to V upon R. Now we have just found the total resistance in the circuit. We know our voltage drop across the circuit, which is our 24 volts. So we can find our current simply by dividing these two values here. So let's write V is 24 volts and our total resistance is 198.7 ohm. So if we plug that in our calculator, so we have 24 divided by 198.7, and our answer is 0.121 amperes, or 121 milliamperes. So this is how you would work a question like this. First we would find the resistance of each loop, then we find the total resistance in the circuit, and then finally we find the current flowing in the circuit. So this was Junior Roberts with realjuniorroberts.com. If there was anything in this video that you wish to get further clarification on, please send me an email, post your questions in the comment below, like if this was helpful, and please subscribe for more videos like these. Thank you for watching.